Okay, so we're going to look at how to solve a system of equations, not inequalities, equations. So when we're solving systems of equations, what we're really trying to find is the point at which all three, in this case, so we have three equations, where all three equations cross. What point is true for all three equations? The other thing is we're looking at three variables now instead of two. So this is not the typical graph that we've been dealing with just x and y, because that's just length and width if we think of it that way. It's up, down, right, and left. But now z adds a third dimension, which is depth. So that's a little bit harder to just graph and find the answer to. So now what we're going to do is we're going to solve the systems using kind of this system that I've set up on this notes page. So I tried to set it up as neatly as I could with these steps to help get us through this, because there are a few steps that we have to follow in order to do kind of elimination a few times. Basically, that's what we're doing. So we're going to label the first three equations. Whoops, didn't mean to go backwards. So we're going to label the first three equations, and we're just going to label them 1, 2, and 3. So that's step number 1. I just like to label them. Equation 1, equation 2, equation 3. Makes it much easier to reference if you just label the equations like this. It's not an essential step necessarily, like it's not going to mess anything up if you don't label them, but it just makes it easier to reference. So now, step number 2, we're going to choose two of the equations to solve using elimination. And this will be equation number 4. So we're going to create a new equation after eliminating. So you want to choose equations that have something that's easy to eliminate. So if I look at equation 1 and 2, there's something that is going to eliminate very, very easily, which is negative z and z. If I were to add those together, I'd get 0. So we want to add the two equations together. So we kind of draw a line, and you can see that happening down here. We're going to draw a line. We're going to just literally add straight down, just like we did when we were using elimination before to solve a system of equations with two lines. So now if I add straight down, I get 3x plus negative x, so that's 2x, because it's really 3 minus 1. 1y plus 2y is 3y. The z's cancel out, which is exactly what we wanted to happen. That's our elimination. And then 3 plus 0 is 3. So this is my equation number 4. I've created a new equation. But now I only have x and y. So what we're trying to do is we're trying to get this down to a manageable position where I know I can solve for one of these variables. Once I solve one of the variables, the rest of it starts to fall into place a little easier. So we have to do a little bit more work for these step 2 and 3 to get to that manageable situation. So now we're going to use, for step 3, we're going to use one of the two equations from step 2. So I do have to use either 1 or 2. And then the third equation. And we're going to solve using elimination to create a fifth equation. Make sure that you eliminate the same variable in this case. If I eliminated something other than z, I'm going to have two equations that only have two variables, but they're two different variables, so now I can't solve again. So make sure you're eliminating the same variable. So if I use equation 2 and 3, and I could have used 1 and 3, it really wouldn't have mattered. I just picked 2 and 3. So equation 2 and 3, I want to eliminate z in this case. So I want to make them match. This is using multiplication to make them match. So when I add straight down, they eliminate, they cancel down to 0. So in order to do that, this needs to have a negative 3 in front of it. And if I multiply this one by negative 3, I have to multiply everything by negative 3. So the first equation doesn't change. I'm not multiplying that one. I'm multiplying the second equation, which is actually equation number 2. This is equation number 3, if I'm looking at the labels. So I'm going to multiply that whole equation by negative 3. So negative x times negative 3 is positive 3. Negative 3 times 2 is negative 6. And negative 3 times 1 is negative 3. Negative 3 times 0 is 0. So now I've manipulated that equation a little bit. I've changed it. I've increased it by a factor of negative 3. But we're not relabeling that one. That's not going to be one of our numbered equations. We just needed it to be manipulated so that when we subtract, or when we add here, these guys eliminate. So now I'm going to add straight down. Negative 5 plus 3 is negative 2. 2 minus 6 is negative 4. 3z minus 3z, yay, that's 0, that cancels. And negative 2 plus 0 is negative 2. So now I have equation 4 and 5, and they only have x and y in them. So now I can solve these just like we did when we were learning substitution and elimination in the first place. So that's step number 4. Using equation 4 and 5, we're going to solve with elimination. So I'm going to scooch down here so that you can kind of see this. So equation 4 and 5. So I'm just going to bring them down. Here's equation 4, 2x plus 3y equals 3. And here's equation 5, negative 2x minus 4y equals negative 2. So by chance, this one worked out very, very nicely. The 2's already matched except for being opposites, which is what we want, because when I add straight down, 2x minus 2x cancels. Yay! So this one lined up really nicely. I'm not going to have to manipulate it like I did with this one where I had to multiply by negative 3, to get something to match. So now I'm going to add straight down. So those guys cancel. I have 3y minus 4y, so that gives me negative y, and then 3 minus 2 gives me 1. I don't want to know what negative y is. Remember, it's negative y because it would be negative 1, right? But I don't want to know what negative 1y is. I want to know what just y is, so I'm going to give that negative to the other side. So that's why y becomes negative 1. So, and you can see I filled it in here. So this is actually the answer part. This is all you're going to be filling in on Alex, is literally the answer, the solution. So you're not necessarily filling out all of this, but we have to do these pieces to get to the solution. So now that I've gotten to this point, and you can, if you go back on your page and you look, step number 5 says use the solution from step 4 in either equation 4 or 5 to find the other variable. So it doesn't matter. You can use equation 4 or 5. Truly doesn't matter which one you use, because both equation 4 and 5 have x and y. If I know what y is and I plug it in, I can solve either equation for x. So I went ahead and chose equation 4 for whatever reason. So I have 2x plus 3y equals 3, and I'm going to plug in negative 1, that should be pink a little bit because it was the whole thing, but negative 1 for y, and then I'm going to start to solve this. So 2x minus 3, because when we multiply that becomes a negative, equals 3. I'm going to add 3 to both sides here. So I end up with 2x plus 6, because the 3's cancel, and then I'm going to divide by 2 on both sides. So I end up with x equals 3. So now I have 2 of my 3 pieces. I need one more piece. I need one more part. So now I'm going to take x and y, and I'm going to plug it into equation 1, 2, or 3. I pick one of the 3 original equations. It does not matter which one. Sometimes there are ones that are a little easier than others, but really none of them are already solved for y, so I'm just going to pick one. So I went ahead and picked equation number 1. So I'm going to go 3x plus 1y plus negative 1z equals 3. So this was equation number 1. If you go back, up to the top there, that original equation, list the 3 of them. This was the first one that was listed. So now I'm going to plug in x and y, and I'm going to solve for z. So 3 times 3 is 9. 1 times negative 1 is negative 1. Negative z comes down, and 3 comes down. I can combine, but 9 minus 1 is 8. So now I have 8 minus z equals 3. So I'm going to subtract 8 to both sides. Make sure you're paying attention to that. This subtraction sign belongs to the z, not the 8. The 8 is positive. So to undo this positive 8, I have to subtract it. So the 8's cancel down to 0. I have negative z come down equals negative 5, because 3 minus 8 is negative 5. I don't want to know what negative z is, though, so I'm going to flip that to positive. So I'm going to switch it to the other side, and they both become positive. So I have z equals 5. So the solution to this question is x equals 3, y equals negative 1, and z equals 5. So again, this is a much more complicated graph than we've been dealing with in the past, because now we have a depth issue. So it's not quite as easy to picture this point when we graph it. That's why we use this method instead. All right, so that was solving a system of equations using elimination. I hope that helped, and I will see you in the next video.